here we go. All right. Sick of the nonsense, right? Okay, so this is also called a line of best fit. So it's a line, usually a straight line, where about half the points are below it and half the points are above. And it has to go in the direction of the data. And the reason why we like to make a line on the data, like on a scatter plot, is so that we can predict the future. So we can predict, well, if this is a relationship, then if this happened, that would happen. A great example of this is, you guys probably aren't too familiar with this because you don't have children, but maybe you remember it from your childhood or you're from your parents talking about it, but you know, like those growth prediction charts, have you seen those at the doctor? Where it'll be like I see it every time I go in, where they'll be like, hey, your kid is this weight, and good, they're about the right height, okay, and then this is their head size, and like, that's correct too. So it's like they can use one metric about you, like your age or your height, to predict what your weight should be or what your head size should be, especially in like child development, that's important. Not so much for like overweight kids, but especially for kids like who are having issues with like bone density and stuff like that, which is a hard thing to catch because a kid could easily be as tall as they need to be, but not as heavy as they need to be for the size they are, and you don't really realize it because they look like they're the appropriate size, but it's literally like their bones aren't as heavy as they need to be, and that's a problem. Like, it could be a problem their entire life. Or head size. Residual is how far each data point is from the regression line. Let me make sure. Yeah, and so residuals can be positive or negative or zero. Tell me, you see how, so for a given x value, you take the observed value and subtract the predicted value. So that's the formula for residuals. Can somebody tell me, you see these that say like D1, D2, D3, D4, D5, DI, I guess? Can somebody tell me one that would be a positive residual? Where the actual value is above what we thought it would be?
D4.
Yes, so this is like a positive residual. Where's one that's negative? D2. That's a negative residual. What would it look like if it was 0? What would the residual be like if it was 0? Yeah, but I mean, like, where would it be on the line?
Oh.
There's actually not an example of it on here. We'd have to draw it on. So what is it? What do you think it would look like? Yes, it'd be exactly on the line. So draw one that's exactly on the line, and that would have a residual of 0 if it's on the line. So the goal of a regression line is to make all these residuals minimal, right? And that would make it fit the data the best. To make all those differences the smallest. So what we're going to do is we are going to, tell me that I didn't set up that horrible problem again. No, I didn't. Good. Okay, so everybody turn. I guess you don't have to. I can just project it. So what we're going to do is we're going to make an equation using technology, which is usually how you're going to do this on the AP test. And it's just that same, remember we did that linear regression thing that we were doing before? Exactly the same. So right now in your calculator in L1 and L2, you're going to put in these lists. This is on page 471, if you want it in front of you. So put those lists in, and we're going to make a y equals mx plus b line for that data. So you're putting those in L1 and L2. Oh, I already have mine in L1 and L2. Do you guys too? Or did you put in something else for a different problem?
I think we did something else for homework.
Okay, so once you're positive that all of these are correct, you're going to go to calc, click linear regression, which is that number 4. We've been using that R value a lot, but there's also an A and a B. You see like the y equals ax plus b. Normally, I know that what you learned in math class is y equals mx plus b. It actually kind of always makes me angry when they do this in calculator programs, because they often put the first thing you want to find is A, the second thing you want to find is B, but like, why not just make it M? That would just, you know, match up to everything that every math student is taught, but why? So, anyway, so I'm going to write this out really quick. Y equals 166.9x plus 115.7. Next thing I'm going to show you really quick is to show you what this looks like. We're actually going to graph it. So if you go to your graph, my graph looks like one of these right now. And if you go to, let's see, is it window? No. Stat plot. So hit second and then the y equals.
Wait, how